Alrighty, nerds. We're going to finish the chapter. Finally. This last unit is called variation, and I don't actually know why it's in this chapter, to be honest with you. I kind of see it because half of it might be considered rational functions. You see, variation describes how two variables are related to one another. Either one goes up or the other goes down. Excuse me, I said that. See, it's already wrong. One goes up as the other goes up, which is the same as one going down as the other goes down. Or they have opposite behavior. One goes up, the other goes down. Okay? When you say that y varies directly as x, what that means is that there is some multiplier, a non-zero constant. We call this the constant of variation, so that we can say y equals kx. It's essentially a slope. In fact, you should have learned about y equals kx, direct variation, way back in 7th grade math. But the very first time you learned how to graph y equals mx plus b, you would have done this right before that. That's how it's supposed to have been learned, at least in the Big Ideas textbooks. I know because my wife taught it forever. So anyway, y equals kx. K is known as a constant of variation. If x goes up, y goes up. If x goes down, y goes down. That's basically how that works. It just means that you're going to multiply one number to x, and that's how you get y. That number could be a positive number, a negative number, or a fraction, but the point is it's literally just multiplying a number to x. We say that y varies inversely as x if there is some k that's not 0, such that x times y equals k, or more commonly, y equals k over x. And see this right here, since x is in the bottom, that is a reciprocal style function, which is technically rational, and I'm assuming that this is why this is in this chapter. So one more time. If y varies directly as x, y equals kx. If y varies inversely as x, y equals k over x. It's that easy. K is the constant of variation. So, a couple direct variation examples. Y varies directly as the square of x. We can instantly write an equation. Since it says varies directly, we know it's k times, and it says the square of x. And now that I'm looking at it, this square of isn't supposed to be there until the second example. I meant for this first example to not be the square of. I meant for it to just be y varies directly as x. Copy paste job, and I forgot to delete. Sorry. So y varies directly as x. I want you to just say y equals kx. Then I'm giving you a y and an x. The reason why is because I want you to be able to solve for k, the constant of variation. So we're saying if y is 9 when x is 6, y is 9, x is 6. What does x equal when y is 12? So we're going to take this 9 and the 6, and we're going to put them here and here where they go appropriately, and we will solve for k, the constant of variation. Then once we know k, we'll plug in y equals 12 and solve for x. See, 9 equals k times 6. So we can get k alone by dividing both sides by 6. So divide both sides by 6, and you will get k equals 9 over 6, which does reduce. You can divide both those things by 3 and get 3 over 2. So k is 3 over 2. Our official direct variation equation is y equals 3 over 2x. Our constant of variation was 3 over 2. And now we plug in y equals 12 and we'll get x all by itself. How am I going to make that 3 over 2 leave that side? I mean, I could divide both sides by 3 over 2, but it's weird to say divide by a fraction. So Michael, what would you do? That's it. Yeah, we're going to multiply both sides by the reciprocal. Multiply both sides by 2 over 3. And what you're going to be left with on the right side is just the x, because 3/2 times 2/3 is 1. But on the left side, we get 2/3 of 12. So 24 over 3, which is 8. There it is. So that is how direct variation works. Not bad, right? Pretty darn simple. Like I said, you should have learned about direct variation in 7th grade math. Now, if you were one of the advanced kids, the middle schools might have made you skip over 7th grade math, and you went to 7th advanced or something like that, which is unfortunate if they did that to you, because you missed how to solve proportions, you missed how to work with direct variation, and a number of other things like percentages and things like that, which are actually very useful. But that's what's up. This is middle school math, ladies and gentlemen. Now this one I did intend to say as the square of x. So this one says y varies directly as the square of x. So not y equals kx. Y equals kx squared. But other than that, it's the exact same style question. We're going to drop in the x and the y that we're told. We'll use it to solve for k. Then once we know k, we'll plug in something else we're told and solve for what is left. Okay. Y is 45 when x is 6. I'm going to put it in parentheses just in case x is a negative number, because it could be. So anytime you're substituting, you technically should be using parentheses. Anywho, we have 45 equals 36k, and you're going to need to divide both sides by 36. Our constant of variation is 45 over 36, which does reduce. You can divide both those numbers by 9. Your constant of variation is 5 over 4. Y equals 5 over 4x squared. Substitute in a y equals 80 and we can solve for x now. On the last question, Michael said we got rid of the fraction by multiplying both sides by the reciprocal. That's the same thing that we're going to do here. We're going to multiply both sides by 4 over 5. On the right side, we just have x squared. On the left, you might grab a calculator, but if you do 4 times 80 divided by 5, it's going to give you 64. Or if you do 4 divided by 5 times 80, either way, you're going to get 64. So you have that 64 is x squared, because these, you know what I don't use often enough? Yellow. Those two fractions canceled each other. Just for good notes, I'm coming up here and I'm doing it again. Yeah. How are we going to get that x alone? Square root. Square root of both sides. Leaves us with x equals, good for Caroline. She says plus or minus. Good for you. Didn't get caught. Plus or minus, and the square root of 64 is 8. Remember, when you cancel a square with a square root, you must have plus or minus. Please don't forget that. Ta-da! We're already halfway finished with the notes. Isn't that easy? I would love for you guys to be able to tackle the homework in class. That would be cool. Questions, comments, concerns on direct variation? Easy peasy. Cool. Scoot. Inverse variation. Y varies inversely as x. That means y equals k over x. If y is -4 when x is 6, you are going to have the ability to solve for k. Once you have solved for k, we will be able to use x equals 15 to find y. Track down that constant of variation. -4 equals unknown constant of variation over 6. Since this says divide by 6, I can get k alone simply by multiplying both sides by 6. And that gives me k equals -24. Y equals -24 over x. Substitute in x equals 15, simplify your fraction, and you know what y is. I can divide both those numbers by 3. Done. You might be wondering, if this is middle school math, why are we even bothering relearning it? Because this should be relearning. I asked Ms. Bluebaum the same question. She said the only reason why she was covering it, because I was just going to skip it. And she said the only reason why she was covering it is because it's found on the SAT. And I was like, you know what? You are right. I know because I tutor for the SAT. And that's the only reason why we're relearning it. This would be a valuable skill for you to have on the SAT. Last question for the notes, and we're calling it a day. Y varies inversely as the fourth root of x. Fourth roots, going all the way back to what we did before the Christmas break. That was chapter 5? No, chapter 5 was polynomials. I don't even freaking remember. 8 maybe. The point is, we did it before the Christmas break. Y equals k over, because it does say varies inversely, so k over, fourth root of x. You are going to need to know your squares, your cubes, and your fourth powers to get this question right, both on the notes and the homework. And you know what? The test also. Make sure you know powers of things. Old knowledge is not allowed to be forgotten. Can't learn and burn. Okay, we're going to drop in y equals -4 and x equals 81. It would be helpful if you knew what the fourth root of 81 is. It is 3. The fourth root of 81 is 3. We actually have -4 equals k over 3, multiply both sides by 3, and you now know that k is -12. Your equation then is y equals -12 over the fourth root of x. And now, substitute x equals 16. What was the fourth root of 16? It is 2. Remember, the fourth root is the same thing as saying the square root of the square root, because they're multipliers. The root types, just like exponents, or when you have a power to power, you multiply. When you have roots of roots, you multiply. So this is 2. We have y equals -12 over 2, which is clearly -6. Questions, comments, concerns? Yes, Luca. So right here and right here, we are not going to say plus or minus. And the reason why is because we didn't cancel a square with a square root or a fourth power with a fourth root. Now, if I had said the fourth root of x to the fourth, then absolutely plus or minus. The reason why is because if x had been negative, raising it to the fourth power would have still been positive and we wouldn't have known. But when you say the square root or the fourth root or any even root of a number, we use what we call as the principal root, which means the positive one only. Cool? But if you're doing it with a variable expression and you're canceling an even exponent with an even root, not evil, even root, then yes, you must use plus or minus. It's a great nerd question. Appreciate you.